Okay, 3.6 common distributions. So histograms can take on several common shapes. Among these distributions are, so if the distribution is symmetrical, it could be normal, bimodal, or uniform. And if the distribution is skewed, it could be right skewed or left skewed. Okay, so normal distribution, a symmetrical distribution of data taking on a bell shape. For example, this occurs when the data clusters around the mean. Okay, so the mean would be here, and tapers off both above the mean and below the mean. And please note, even if a graph is not perfectly symmetrical, it can fit the definition of a normal distribution. Okay, bimodal distribution. This occurs when there are two humps in the distribution. Example, it occurs when a population consists of two groups with different attributes, such as adult shoe sizes. Okay, the first hump could be the first mode, maybe men's shoe sizes, and then the second hump, women's shoe sizes. Okay. Now, uniform distribution. We use uniform distributions often. This occurs when the probability of all outcomes of an event are equally likely to happen. For example, tossing a head or a tail on a coin both has a 1/2 probability. And then for this one, this is rolling a die. All of the outcomes on a 6-sided die have the equal probability of 1/6 of probability to be rolled. Okay, as you can see, in a normal distribution, all of these have the same probability. Okay, so all of these three are symmetrical. Now, we could also have a skewed distribution. So a skewed distribution is non-symmetrical distribution of data, and we can either have it positively skewed or right skewed. Okay, this occurs when the tail is pulled to the right. Okay, when the tail is pulled to the right, we have mode occurs at the hump, then median, and then mean. Okay, in that order. Okay, so then an example of this is the number of children families have in Canada. So most people have 2 children. So most would be like the mode of 2. And then there's a couple that are like less than 2. But as you go higher and higher, maybe 3 children, maybe 4 children, 5, 6, 7, there's going to be, it tapers off. It's going to be less and less families that have that many children. Okay. Another example of this is scores on a difficult test. Okay, the whole hump is going to be to the left because it was a difficult test. So that's going to reflect that the scores are lower. Okay, most students will average, let's go 60 perhaps. Okay, some will average lower than that, but in order to get high, like a high score on this test, very, very, very few people will have a high score. Higher score. Okay, and now negatively skewed or left skewed. This occurs when the tail is pulled to the left. And in order, we have mean, then median, then mode. Okay, an example of this is scores on an easy test. Okay, this hump is going to occur because most scores are going to be very high. Let's just say 90%. Okay, but scores less than 90% on an easy test won't occur very often. Okay, and then the age at which people retire. Many individuals will retire around the same age. So again, this would be maybe age 60, 65. Okay, very few people are going to retire maybe at 40 years old. Okay, and most of the individuals retiring are going to cluster there around the 60. Example 1, analyze the numbers in each of the data sets below and determine if the data represents normal, bimodal, or uniform distribution by first sketching its bar graph or histogram. So A pair of dice were rolled 75 times and the sum of the numbers on the dice were recorded. So we are going to graph the sum on the die versus the frequency. So the sum of 2, the frequency is 1. Okay? The sum of 3, the frequency is 3. The sum of 4, the frequency is 6. Okay, sum of 5, the frequency is 8. Here we go. Okay, the sum of 6, the frequency is 11. The sum of 7, the frequency is 15. Oh, I have to change the graph. I apologize. Frequency is 15. So we'll put it up there. Okay, the sum of 9, the frequency is 9. The sum of 10, the frequency is 5. Oh, 8, I'm missing. Frequency was 12. And that was 12. 9 is 9 and 10 is 5. 9 is 9. And then 10 is 5. 11 and 4. Okay, and then 12 and 1. Okay, so let's take a look at this. How many humps are in this graph? Okay, if we think about this and we make this curve, I would say this is one hump. One peak slash hump. And it's centered. So this is a normal distribution. B, a class of grade 6 and grade 1 students each measured their heights. They recorded them in the table below. So we have height and then we have frequency, right? So then this is X, this is Y. So for the height of 105 to 110, we get a frequency of 1. 110 to 115, we get a frequency of 11. 115 to 120, we get a frequency of 8. Okay, 120 to 125, we get a frequency of 5. 125 to 130, we get a frequency of 3. 130 to 135, we get a frequency of 2. 135 to 140, we get a frequency of 0. 140 to 145, we get a frequency of 2. 145 to 150, we get a frequency of 5. 150 to 155, we get a frequency of 8. Okay, 155 to 160, we get a frequency of 11. And then 160 to 165, we get a frequency of 3. Okay, so this is how our graph looks, and if we smooth it out, it would look like this. Okay, so there are clearly 2 peaks here, or 2 humps. So this is bimodal. Okay, again, bimodal is there are 2 different numbers that occur the most often. Okay, likely this would be from the grade 1 heights, and this being from the grade 6 heights. C, a die is rolled 50 times, and the number on the face is recorded and graphed. So die face would be X, frequency would be Y. So the die face, 1 showed up 8 times. Okay, so 1 showed up 8 times, 2 showed up 9 times, 3 showed up 8 times, 4 showed up 10 times. And you have to think, when we're looking at these numbers, the die was rolled 50 times. There are 6 different outcomes. 50 cannot divide by 6 evenly. But these are the outcomes. 5 appeared 7 times, and 6 appeared 8 times. Okay? If we look at this and we smooth it out, yes, we can go like this. However, these are so close together, they're all within 1 or 2. I'm going to call this a uniform distribution. Okay, again, 50 does not divide evenly by 6, but all outcomes here are generally like around each other. Let's go consistent. Okay, example 2, in each case, predict the shape of the data distribution and give a reason for your prediction. So the heights of the members of the Toronto Raptors basketball team. So if you look at the heights, I would say most people are around the middle. Okay, pretend these are people, not frequency. Okay, most people are around the middle. So I think it's going to be normal, right? There's going to be a few shorter people. These are going to be point guards. Okay, there's going to be a few that are taller. These are going to be centers. But most of the people are going to cluster in the middle. Okay, so I would say normal distribution. Because some players will be short. Some will be taller. And most will be around the average. Okay, an alternate explanation for this, it could be uniform. Okay, so you have two, like say 4 point guards, they're all going to be the same height. For just normal like forwards, they're all going to be the same height, and a couple centers, they're all going to be approximately the same height, right? So when we're looking at the distribution of the heights, it could be approximately the same across, okay? Or this could be uniform if there are the same number and height, and obviously it's like approximate, right? Height of each position, essentially. I know that there are less centers, so it's not going to be as heavily weighed, but you could potentially have more centers on a team, so that's another an alternative answer, okay? Now, B, the cost of 1 liter of gas in the city of Ontario. I'm going to assume that that would be uniform, okay? So, like, gas at different gas stations typically have the same price. So let's say this is uniform. Okay. And then C, the masses, so like the weights of players on the Canadian Olympic men's and women's hockey teams. Okay. So whenever we're looking at that split for men and women, it's likely going to be like this. Okay. Women usually weigh less, men usually weigh more. Okay. So I'm going to say bimodal. Women's weights or masses will be clustered around one number, while men's weights will be clustered around another number.